Hi everyone. In this video, we'll discuss how to build and test a predictive model using the decision tree method. Decision tree is a very popular data mining method. It is a non-parametric and non-linear method. Decision tree models are advantageous because they are conceptually easy to understand, yet they readily accommodate non-linear associations between input variables and the target variable. They also can handle missing values without the need for imputation. Note that decision trees do not have any required assumptions, such as normality or linearity, so we have much more flexibility in building predictive models. Additionally, decision trees can be used for both regression models, which are models with an interval target variable, and classification models, which are models with a categorical target variable. We will model the data using decision trees first, then compare decision tree models to other models later in the other videos. Decision trees are logical rule-based methods. A decision tree represents a hierarchical structure of variables, including the root node, a parent node, and child nodes. The bottom nodes of the decision tree are called leaves. The root node is split into two or more branches using the condition that best separates the individuals of each class. If the variable is categorical, the branches represent separate classes of the root node. On the other hand, if the variable is interval, the branches represent specific ranges of the node. At each split, a separation condition will be used to determine how to split the parent node into child nodes. The process continues until some stopping rule is satisfied. This process is called recursive partitioning. Common splitting criteria to choose the best separation of the node include chi-square, Gini, and entropy. SAS Enterprise Miner uses the so-called log-worth algorithm. To add a decision tree node, on the Model tab, select the decision tree node icon. Drag the node in the diagram workspace and then connect it to the data partition node. We can choose to prune the tree manually using the interactive method. On the Properties panel, in the Train group, select the three-dot button for interactive. This will open the tree view window, which allows us to prune the tree by splitting one node at a time. In the tree view window, we can see the root node with information about the target variable. It is a binary variable with two levels, 0 and 1. The ratio of 0 and 1 is 50-50. And we can see the sample size for train and validation sample in the ratio of 60-40. To split this node, right-click on the node and select Split Node. The Split Node window appears that lists the candidate splitting rules ranked by log-worth. SAS Enterprise Miner calculates the log-worth values for all variables and rank them from high to low. For example, the results show that the gift count36 rule is the most important variable, should be split first. We can click Edit to edit the rule. We can change the split point value or add a new branch. Note that by default, SAS Enterprise Miner will build a two-branch decision tree model. Then we continue to do that for each node. For the purpose of this course, I would not recommend using this method because this is a time-consuming process and we need to understand thoroughly each variable and make the split rule decision at each node. In this course, we'll use automatic pruning method. There are some settings we need to pay attention to and make decisions when we build decision tree models. On the Properties panel, in the Splitting Rule group, we see maximum branch and maximum depth. Maximum branch specifies the number of partitioning splits. The default is binary splits, 2. You can change to other numbers, which makes a tree. I would suggest at least build 3 different trees with 2 branches, 3 branches, and 5 branches. Maximum depth specifies the number of generations in the decision tree. The default value is 6. Adjusting maximum depth allows for larger trees that are more sensitive to complex input and target associations. In the node group, we can adjust leaf size. Leaf size specifies the minimum number of training observations in the leaf node. The default value is 5. This will prevent orphan node. By having many observations in the leaf node, we can minimize the tree growth. In the subtree group, we see assessment measures which indicate the measure to select the best tree based on the validation data. SAS Enterprise Miner provides 4 measures: decision, average square error, misclassification rate, and lift. The default is decision, which selects the tree that has the largest average profit and smallest average loss. This method requires us to define a profit or loss matrix, also called payoff table. Average square error method is usually used for an interval target variable, and misclassification rate is used for categorical target variable. Finally, lift method evaluates the tree based on the prediction of the top n% of the rank observations. In this course, we mainly use misclassification rate and average square error. As indicated, if the target variable is categorical, the misclassification rate will be used along with the classification matrix, also called confusion matrix. Typically, we interpret the classification matrix by looking at the sensitivity, specificity, and precision rate. The textbook explains in more detail about these values. Note that average square error, or ASE, can also be used with a binary target variable. A common question is when we should use misclassification rate and when we should use ASE. In addition to the scale of the target variable, there is another way to make this decision. Basically, we need to make that decision based on the type prediction we want. Misclassification rate should be used for decision optimization, in which we consider a primary decision corresponding to the primary outcome and a secondary decision corresponding to the secondary outcome. Using the classification matrix, we can calculate the prediction accuracy and misclassification rate. We would want to maximize accuracy and minimize the misclassification rate. On the other hand, average square error is used for estimate optimization. Specifically, estimate predictions are the probability of the primary outcome for each case. Primary outcome cases should have a high predicted probability. Square error is the squared difference between the target and prediction. So ASE is related to the amount of bias in a predictive model. A model with a lower ASE is less biased than a model with a higher ASE. In my opinion, we should look at both ASE and misclassification rate. In this example, our prediction is mainly about estimation optimization. So I will use the average square error for the model evaluation purpose. So I change the assessment measures to average square error. Right-click at the decision tree node, select Run and click Yes. Again, this process might take a little bit long, so please be patient. Okay, the run is completed. Select Results. We will examine the decision tree first, so we expand the tree window. This is a tree that is automatically trained and pruned by SAS Enterprise Miner using the log-worth algorithm. We can see that each node is split into 2 branches only because we choose maximum branch of 2. In some cases, the node needs to be split more. We will see the same node is split again. Note that if you run this example, your tree might be slightly different. The reason is that decision trees are very sensitive to changes in the data. Since we use random sampling, you and I might have different train and validation data. In order for us to get exact solutions, the sampling sequence must be fixed in our SAS Enterprise Miner. In this course, you do not have to do that. If members of the same group see some minor differences in the decision tree, it should be acceptable. Since data mining focuses on predictive modeling, if these models have similar predictive power, then the results are considered acceptable. In order to interpret this tree, we need to go from the top level and use the results for validation data. The root node shows that 50% of respondents decide to give gift to the charity, while other 50% decides not to. Under the top level, gift count 36 months is considered an important factor, and it further differentiates the giver from the non-giver. Among respondents that have given less than 2.5 gifts last 36 months, only 42.8% will decide to give the gift. On the other hand, among respondents that have given 2.5 gifts or more last 36 months, almost 56% will give the gift this time. The next important variable is the amount of time since last gift. Among respondents that have given gifts less than 17.5 months ago, 61.3% will give gifts this time. And among respondents that have given gifts 17.5 or more months ago, only 50.4% decide to give gifts this time. And we can go on to interpret other nodes in the decision tree in the same way. Let's go back to the results. We will look at the leaf statistics. Basically, the leaf statistics show the frequency percentages for each target class level within each leaf from the training and validation data. The most common level in a node is the predicted value assigned to that node. In this case, we see the frequency percentage for level of 1 gift giver between training and validation data. And we have 9 leaves in the tree. In this case, we see the differences between training and validation data are very small, which is good because that may mean the results are consistent and valid. The next results we look at is fit statistics. We can see that misclassification rate for training and validation data is almost the same, about 0.42. Similarly, average square error is also similar between training and validation, about 0.24. These mean consistent and valid results. Whether these values mean good predictive power or not, we will need to compare these with another model. We can also see cumulative lift chart. You can read more about lift chart in the book. Note that the cumulative lift chart in SAS Enterprise Miner is the same as lift chart in the textbook. Basically, the x-axis shows the percentile and the y-axis shows lift. Keep in mind that the default no model is a horizontal line intersecting the y-axis at 1. If we contact a random 10% of the population using no model, we should get 10% of the gift giver by default. This is what we mean by no lift or lift equal 1. The chart in the results shows that using the given model, we should be able to capture 13 to 14% of the gift givers if we contact the respondents in the top 10 percentile. That is almost 1.5 times as many as if we use no model. So that is our lift over the baseline. Here is another example using the same chart. We can move to the right on the lift curve and contact the top 20% of our respondents. And we would end up with a lift of about 1.3. This means that by using the model, we could capture about 20 times 1.3 equals 26% of the gift givers if we contact just 20% of them. This number shows that using our model is better than no model. The higher the lift index, the better the model. Again, we'll need to compare this chart with other models. Another chart we can use is ROC chart. The ROC chart, or Receiver Operating Characteristic chart, shows the values of the true positive fraction on the vertical axis and the false positive fractions on the horizontal axis. Basically, an ROC chart reflects the trade-off between sensitivity and specificity. Sensitivity refers to the probability of giving gifts, reflecting an ability to correctly predict gift givers. Specificity refers to the probability of not giving gifts, reflecting an ability to correctly predict non-gift givers. The straight diagonal line is baseline. The larger the area between the RC chart of the model being evaluated and the diagonal line, the better the model. Note that we only have cumulative lift chart and RC chart for classification models where the target variable is categorical. If the target variable's interval, SAS Enterprise Miner will not generate these charts. Another important result we need to look at is subtree assessment plot. We go to View, Model, and select Subtree Assessment Plot, which shows tree evaluation information. Since we chose average square error, this plot shows ASE of the trees automatically generated with 2 leaves, 3 leaves, 4 leaves, etc. up to 17 nodes, where it stopped because that includes every possible variable. Looking only at the train results, the blue line, it appears that the maximal tree with more than 17 leaves or more generates the lowest ASE. However, the validation results, red line, show that the tree with 9 leaves generates the lowest ASE. Basically, the performance on the training sample becomes better and better as the tree becomes more complex. However, the performance on the validation sample only improves up to a tree of approximately 9 leaves and then diminishes as model complexity increases. Note that using the same sample, both to evaluate input variable usefulness and to assess the model performance commonly leads to overfit models. Accordingly, looking at an assessment plot based on validation data provides the solution. SAS Enterprise Miner determines that the optimal number of leaves is 9. We can change the assessment plot to using misclassification rate, and the plot shows similar results. That is how the tree ends up with 9 leaves. Next, the output shows us more detailed and complete results in numbers. We have seen most of them in separate windows, but the output shows all of them in one window. We can extract the classification metrics from this output to calculate the sensitivity, specificity, and the prediction precision rate. One important output we want to see is variable importance. The output shows these results as well, but sometimes it is hard to find. I will show you how to get this result directly. We go to View, Menu, and select Variable Importance. In the Variable Importance window, we see the importance scores. Variable importance is an indication of which predictors are most useful for predicting the target variable. The relative importance metric is a number between 0 and 1. In this case, we can see gift count 36 is most important variable, followed by gift time last, and then median home income, etc. This result matches with the tree as we interpreted before. Let's say we want to build another decision tree model with different settings. For example, a decision tree with 3 branches. On the Model tab, select Decision Tree node and drag it to the diagram workspace. We will change the name of this node so it makes more sense. Right-click on the node and select Rename. We will call it Decision Tree 3 Splits. Then we connect it to the Data Partition node. We will make some changes in the setting. In the Splitting Rule group, we change maximum branch to 3. In the subtree group, we change assessment to average square, and we run the tree again. The run is completed. Select results. Let's examine the tree first. We can see that the gift count 36 node is split into 3 branches instead of 2, depending on the log worth. SAS Enterprise Miner decides to split a node into 2 branches or maximum 3 branches. For the fit statistics, we can see that misclassification rate is almost the same. The average square error is also almost the same. If we look at the subtree assessment plot, we see that the optimal number of leaves have changed. SAS Enterprise Miner determines the optimal number of leaves is 12. As we can see in leaf statistics, we see the total of 12 leaves. That is how to build and run decision tree models using SAS Enterprise Miner. Thank you and bye now.